going to talk about Laurent Series. And let me start with the example we've seen before. Right, if we look at this function, that should actually be a z because we are working in the complex plane. F of z is 1 over 1 minus z. This has a power series by just using regular kind of geometric series knowledge. This is the power series, but this is only true when z is equal to, when the modulus of z is less than 1. Right? So essentially what this says is that this works perfectly well on this circle, this open circle. So anywhere in here, go right ahead and use this. The problem is that sometimes you might want to use this function outside of this region. If that's the case, what can you do? Well, that's where Laurent series come into place. You can't use a power series. The power series will only get you this much. But if you want to figure out the value out here, if you want to work like somewhere around there, you can use Laurent series, which are essentially, if power series look like something like this, a naught plus a1, z to the 1 plus a2, z squared plus da 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 da. A Laurent series looks like this. a1 plus a1 z1 plus a2 z squared plus da 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 da. Well, but you also get to go the other way. A negative 1 z to the negative 1, in other words 1 over z, plus a negative 2 z to the negative 2 plus da 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 that way. So by allowing yourself all of these terms here, you can get convergence of the series outside of this region. And how would we do that? Well, let's take a look. So outside, let's use a different tone of voice. Outside of z less than 1, we know, in other words, if you consider the blue region out here, so that's the region where modulus of z is where the modulus of z is bigger than 1. We know that modulus of z is bigger than 1, so 1 over z has to be less than 1, which means that we have something good here. This is like a geometric series. So we have a geometric series in 1 over z. So we have a geometric series in 1 over z, which is good, right? So this is going to be our strategy, is that, okay, if we can't have a geometric series where z is less than 1, well, maybe we can get 1 over z is less than 1. And we might be able to generalize that to 1 over z minus z naught less than 1. Well, so how might we get that? How would we find the Laurent series? We do this, except we want the geometric part to be 1 over z. So I can factor out a z out of both of these, and I get 1 over z minus 1. So this is equal to 1 over z times negative 1 over 1 minus 1 over z. And this part here is a geometric series, which equals negative 1 over z times n equals 0 to infinity of 1 over z to the n. So here's the deal. If you're in the red area, use the power series z to the n for this function. If you're in the green area, use the Laurent series negative 1 over z times integral from n equals 0 to infinity 1 over z to the n, and now we'll work outside in the blue area. So really what Laurent series are good for they're good for if you want to exclude some certain amount, if you want to get the area of some donut or possibly infinite donut, that's what Laurent series gives you. If you want to cut out a whole of something, or if you have to cut out the whole of something, for instance in this case, Laurent series are good for that. Enjoy.